Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, no problems today. We're going to talk about something, the reason for the seasons. And I'm not talking about Christmas. I'm talking about spring, summer, fall, and winter. Why do we have seasons? Some places don't, sort of. But what's up with that, right? So the key thing, you know what the key thing that drives everything, all of the weather on the planet, really is the energy from the sun. So sun energy comes on the sun. You know this. You've been on a hot day and you thought, oh my gosh, it's so hot. Even on a cold day, there's energy coming from the sun. That energy matters, but here's the key question. How does the energy of the sun get distributed? The key is that we have this. The energy from the sun is unevenly distributed, so we have uneven heating on the earth. So some places get more sunlight than others, more energy from the sun, and therefore they get hotter. But let's talk about what makes a difference here. And what does this cause, by the way? Let's actually answer this question. What does uneven heating of the earth cause? It causes winds. Winds are caused by uneven heating. It causes currents in the ocean. It causes weather. It causes rain, snow, sleet, precipitation. So this is a key player. If we're trying to understand what causes weather, meteorology, we're studying meteorology, is the uneven heating of the earth. And so we need to understand how the earth is unevenly heated before we can understand how these things happen, how wind and currents and weather and rain. So this is a really big monster idea right here, is that we have uneven heating of the earth. Now, why do we have uneven heating of the earth? Well, to understand this, we need to understand that the earth has two big types of motions that it has. And you probably learned this in 5th grade, okay? There is rotation and there is revolution. The earth rotates every 24 hours, right? It spins, the globe spins every 24 hours. So in terms of uneven heating, in the middle of the day, some parts of the earth are getting full sun and then it's dark on the other side. So that's uneven heating by the actual day. But revolution, this is 365, actually and a quarter, days for the earth to revolve around the sun. And as it revolves around the sun, that also causes uneven heating of the earth. Now I think this one we understand. Rotation, it's going to be colder at night, typically, there's exceptions of course, than in the day because the sun is shining. And so that's going to cause some uneven heating of the earth. But the revolution one is the one that gets people all like, it doesn't quite understand, it doesn't make sense. Why does this change and cause the seasons? So what causes the seasons is more than rotation. This actually is really revolution. So because at different times of the year we have different seasons. We know this, right? In the winter it's colder and in the summer it's hot, and in between is fall and spring. And so let's talk about how revolution changes and why they are the reason for the seasons. So as we talk about the earth revolving around the sun, I want to show you 3 pictures from 40 degrees north latitude. Now, you may not have ever thought about this, but take a look at picture number 1. In picture number 1, this is in what's called summer solstice. Again, what that is, I'll tell you later. So it's June 21st. So on June 21st, you'll notice that the angle of the sun there is 73 degrees. Pretty high in the sky. All right, let's flick forward to the fall equinox, the fall equinox. So this is going to be like September 21st. Notice the angle of the sun is now not 70 whatever degrees, but it's 50 degrees. So you see, the sun isn't always at the same height. Every day it changes. So in the summer it's the highest it can be, and then in the fall it's lower. And now let's take a look at it in the shortest day, which is December 21st, which is called the winter solstice. And notice the angle now is only 26.5 degrees. Interesting, right? You see, so the sun appears to move. Now the earth is revolving around the sun, but for some reason the sun's height if you're at a particular latitude, 40 degrees north, is going to change with time. Interesting. So if you go out, now right now we're studying this in the spring. It's, what is it, April and change. And so we're pretty close to the middle picture right here, right? At March 21st, it's early April, so yeah, you can kind of see where we're going to be at. And then as the summer comes on, it's going to get higher and higher and higher. Okay? Now, I haven't explained why that is, but that is what causes uneven heating of the Earth. Let's label an image. This is important. So take this image here, and I want you to label it because it's important to kind of take a look at the Earth. So a key thing, let's write this down too, is the Earth has a tilt. So the Earth, and maybe you've seen this before, but the Earth is tilted toward the sun at 23 degrees. Like it might be 23.5 degrees. And that tilt is what causes the seasons. So let's take a look at the big picture there that's in your notes, and I want you to label some things. So in the first picture at the top, or let's say over here on the side, pardon me, is this will be, and we're going to do it from the perspective of the northern hemisphere, because we live in the northern hemisphere. Sorry, people from Australia. In the northern hemisphere, this is going to be summer, all right? This is summer right here. And then right here, this will be fall, winter, spring. Now notice the tilt. The tilt's the same. So let me sketch it. We've got that image there. It's going to be the same here, here, and here. So it's rotating in this direction around the sun. Here's the sun. Now the sun's super big, but I'm going to draw it small. And notice that since it keeps that tilt, that the sunlight is coming here, right, during this time of the year, and it's coming here at this time. You know, and it's also coming parallel and hitting the southern hemisphere. So if you think about it right here, this is the northern hemisphere and this is the southern hemisphere. And the interesting thing is that this is the summer and this is the winter, and it's caused by the tilt, and here it's going to hit everything kind of at the same time. So why do we have uneven heating of the Earth? It really comes down to the tilt of our planet. So if you think about it this way, it's going to be hot here and cold here, or colder. How come? Now what a lot of people think is they think it's because the lines are closer together and then they travel further. But we got to realize that the sun is a long ways away, and this difference is just several, 100 miles. So that's actually not the deal. It's actually better to look at this picture right here. So if you look here at the Earth, now here it's going to be in this orientation right here, right? So it's going to be during the winter in the northern hemisphere, because this is tilted away, is that you can see that there is at the top here a large area, because as the sun comes in at a steeper angle, right, and the Earth is curved, it's going to cover this much area. But if we're down here, that same sun, if you think about it, this is a smaller area of the Earth, close to the equator. So the amount of sunlight coming here and here is the same. So let's say this coming in at 100 units of solar energy. But that 100 units is spread over a large chunk of land, where this is still 100 units, and it's over a smaller chunk of land. So the amount of energy per square meter or whatever on the Earth is going to be higher near the equator than near the northern hemisphere poles. So the reason the winter time is colder is because the energy is more dispersed. It's spread over a larger period of time. The same amount of, the amount of energy coming to the sun doesn't change. It's so many amounts of energies, all right, calories and joules coming to the Earth. And that doesn't change. But if it has to be spread out over a larger swath of land, it's more dispersed. We could talk about a term called the energy, or actually the solar density. Right? It's basically the number of joules per square meter. And the number of joules per square meter here is big because it's a small area, right? If you think about it, energy divided by area. So if you have a small area, think mathematically, right? Energy divided by smaller area is a bigger number. So you get more energy per area, so that's why it's hotter at the equator than it is at the North Pole in the winter. But now flick that around, and we come over to here, right? And in the summer, now you are getting more direct sunlight. So in the summer, you're more like this in the northern hemisphere. And so in the southern hemisphere is going to get them more spread out. That's the big idea. And so I really want you to make sure you can summarize the reason for the seasons. By the way, when you're in the middle here, like it's spring and the fall, everybody gets the same amount of energy and sunlight. Which leads us to this chart. So we've got like 4 kind of critical moments in how the seasons rotate, and you can see them. They are the summer solstice, the fall equinox, the winter solstice, and the spring equinox. But let's just put the dates. Now we're doing this from the perspective of the northern hemisphere. Again, sorry to my Australian friends. But the summer solstice is June 21st. And the amount of sunlight, now we're going to do a Houston perspective because we're in Houston, right? Is the amount of sunlight in the summer. So interesting thing is because of the rotation of the Earth, you actually get more hours of sun. So you get 14 hours and 3 minutes. And then compare that to the North Pole, they're going to get 24 hours. Sunlight all day long. Crazy, right? And then the fall equinox, which is September 22nd. It's actually like 21, 22. It's right in that between. All of them will be the 21, 22. It's September. And in Houston, we're going to get 12 hours of sun. In fact, the whole world gets 12 hours of sun on September 22, regardless of where you are, and so does the North Pole. The winter equinox, which is December 21st, again, maybe good the 22nd, it gets 10 hours and 14 minutes. So in Houston, we only get 10 hours of sunlight. Now note here, North Pole, they get none. It's just dark all day long. That'd be kind of depressing. And in the spring, guess what? We're back to the 12-hour thing. And that's, of course, on March 21st. So it's important to see that this is caused, again, by the revolution of the Earth and the tilt of the Earth. And I'm going to have you do an activity on your own, a little lab with like a basketball and a flashlight, so you can kind of see what this looks like and send me a video. So Houston, we know the reason for the seasons, the uneven heating of the Earth, which is primarily caused by the tilt of the Earth and the differing solar densities as the sunlight hits the Earth. Houston, this reason for the seasons, we are going to see you in class.